Okay, so I went ahead and gave you a little summary here. So, like I said, either you are going to derive these formulas or maybe you want to create some flashcards for yourself. I will not be giving you any formulas on any upcoming test or quiz. So you have to know how to either know the formula just by heart or know how to derive them. Okay, so we're going to do some evaluation. So evaluate sine of 5 pi over 8. Okay, so last time we did problems like this, we did it with addition or subtraction. 5 pi over 8 is not a fractional value that lives nicely in the unit circle. So if you can recognize this either as a half angle or a double angle, then that's going to be to your advantage. So what do you think here? 5/8, can I write it as a double angle or a half? I think a half is easier. So this is a half times 5 pi over 4. So this is like saying 1/2 times alpha. And so alpha is 5 pi over 4. Okay, so we're just going to use our formula. We're going to use the half angle formula for sine. Sine of alpha over 2 equals plus or minus the square root of 1 minus cosine alpha all over 2. So let's leave the plus or minus alone for a minute. This is going to be 1 minus cosine 5 pi over 8 or over 4? Over 4. All over 2. Okay, what is the cosine of 5 pi over 4? Negative root 2 over 2, so this is going to be 1 plus root 2 over 2 all over 2. Okay, that's gross. We just got to get a common denominator and stuff. So let's see, this is going to be 2 over 2. So we're going to get 2 plus root 2 all over 2 all over 2. Which turns into 2 plus root 2 all over 4. Oh yeah, I'm sorry. And so then this becomes the square root of 2 plus root 2 all over 2. Now we have to decide if it's a plus or a minus. So to determine if I have a plus or minus here, I have to look at the original angle. So 5 pi over 8. Where's 5 pi over 8? Yeah, second quadrant. So we're in quadrant 2. Is sine positive or negative in quadrant 2? Positive. So here's your answer. You could just leave it. You don't have to put the plus there. But it is positive in quadrant 2. So let's do this next one. So we can write negative pi over 8. Again, not a value that is going to be able to use addition or subtraction. This is the one we tried to do last time, and we had to change the denominator to make it work. So we can write this as half times negative pi over 4. So you don't need me. Why don't you go ahead and try it? So remember that there are 3 versions of the half angle formula for tangent. So you can use any of the 3. I decided to use the one in the middle because then I don't have to think about if it's plus or minus. It's automatically going to work itself out. So I did sine alpha over 1 plus cosine alpha, and I ended up here, negative root 2 over 2 plus root 2. How many of you got to the same place? Great. If you need to rationalize, you can, plus you. 2 plus root 2. So negative 2 root 2 minus 2 all over. Oh, wait. Is that how that works?
Should be a minus.
Yeah, it should be a minus. You got to do the conjugate when you have a binomial term. Negative 2 root 2 plus 2, 4 minus 2. So is that 1 minus root 2? Yeah. Okay, let's take a look at another kind of example here. Evaluate cosine alpha over 2 if cosine alpha equals negative 3/5 in from pi to 2 pi. So that's in quadrants 3 and 4. Uh-oh. Okay, so we did some problems like this before. We did it with, in the first section, 7.1. So first of all, I'm using the half angle formula for cosine. So let's go ahead and get that written down. Plus or minus, whoa. Is it 1 plus cosine or 1 minus cosine? Plus, Coco is good. Okay, okay. Do I know if it's positive or negative? Well, it tells me that cosine alpha is negative 3/5, and I'm between pi and 2 pi. So which of these 2 quadrants gives me a cosine alpha of negative 3/5? Third quadrant here. So we'd have negative 3, negative 4, and 5. So we're in the third quadrant, so we're going to choose the negative one here. All right, so we've got negative root 1 plus, what's the cosine of alpha? It's right there, so you plug it in, negative 3/5 all over 2. And then you just simplify. Oops. So 5 minus 3 all over 5 all over 2. So we get 2/5 over 2, which turns into 1/5, or negative root 5 over 5. Okay, now wait a minute. So alpha is here in quadrant 3, but where's alpha over 2? Is alpha over 2 also in quadrant 3? No. Okay, so we had alpha, which was living between pi and 2 pi. What we're interested in is knowing where's alpha over 2. So if I take all these terms and I divide by 2, I get pi over 2 less than alpha over 2 less than pi. Where is this? This is quadrant 2. Well, the good news is that, should I still be negative? Is the cosine positive or negative in quadrant 2?
Negative.
It's negative. Okay, so it's not because of alpha being negative. It's because alpha over 2 is in quadrant 2.
But
So
sometimes if it's in quadrant 4 or something, would you change the sign?
yeah, you would change the sign. Yeah, so for example, if instead this had given us originally, pi over 2 to pi, and then we divided by 2, so let's say originally this angle alpha was in quadrant 2, and I divide it by 2, I end up in quadrant 1. Cosine's positive in quadrant 1. So you have to look at where alpha over 2 lives, and that's the answer.
So then you just change it.
Yeah, or you just don't think about the sign until you get to the very end.
Oh, okay.
Yeah, that's probably the easiest way to go about it. Okay, a couple more examples here. Okay, this problem right here is very similar to questions you're going to see in calc. You have to lower powers, and it's not always pretty. I don't even know if I gave us enough space to do this, so we'll have to write nice and small. So it says, use the formulas for lowering powers to rewrite the expression in terms of the first power of cosine. Huge skill here. Okay, so first of all, I have to think back to the formulas that I have. I've got this one here. So the cosine squared formula, and it turns into this. Coco is good. Okay, so what I want to do is I want to rewrite this thing so that it's in terms of cosine squared. So this is going to be cosine squared quantity cubed using power of a power rule. Okay, so now I'm going to substitute in 1 plus cosine 2 alpha all over 2 cubed. And yes, that means you have to cube this. So you can make things a lot easier on yourself if you notice that the denominator is just a constant. The denominator is just 8. So let's factor out the 8 here. So I've got 1/8. And then if we expand, I've got 1 plus cosine 2 alpha quantity cubed. So it's a binomial. You can either expand it longhand or you can use the binomial formula for expansion. So let's see, if I use the binomial formula for expansion, how many terms will I have when I'm all said and done? 4 terms. So the first term is 1 cubed. And the last term is going to be cosine cubed 2x. And because this is plus, I've got plus in all terms here. What are the coefficients of these next 2 terms? 3 and 3. So from Pascal's triangle, right here. Okay, so then what goes here? Cosine 2 alpha. So cosine 2 alpha to the power of 1, and then this one's going to be cosine squared 2 alpha. So we're increasing our powers. This is cosine to the power of 0, cosine to the first power, cosine squared, cosine cubed. Okay, so expanding. If you don't get the binomial formula, then just multiply it all out. Okay, do we have all terms in the first power of cosine? No. Any guess what happens next?
Split it up.
You do it again. Yeah, we need to get this one to be a power of 1, this one to be a power of 1. So I'm going to move way over here. We've got 1/8, 1 plus 3 cosine 2 alpha plus 3. Okay, now we've got cosine squared 2 alpha. So we know that cosine squared is 1 plus cosine over 2. But what goes here next to the cosine? Is it alpha, 2 alpha, or 4 alpha? So notice when we went from here, cosine squared alpha, to here, it turned into cosine 2 alpha. Now we're going from cosine 2 alpha into cosine 4 alpha. Okay, if you need to do a little substitution there, you could say, well, let's here let u equal to 2 alpha. And so then this is going to be cosine 2u, which is 4 alpha. Okay. Whew. Plus, we've got cosine cubed 2 alpha. I don't have a cubed thing formula to plug in. I only know about the squared one. So split it up. Cosine 2 alpha times, right, I can break this apart into a monomial, a single term, power of 1, and then the squared. So cosine 2 alpha, and then I'm going to write it up here, cosine squared alpha. That's what's going to go in right there. Cosine 2 alpha times cosine squared, oops, I should say 2 alpha. Those two things multiply to be cosine cubed, so I'm breaking it down. This is squared. Okay, so then inside here, we put 1 plus cosine alpha, 2 alpha, or 4 alpha? 4 alpha again, all over 2. And there's really like a big bracket here. Okay, so this is one of those cases where the algebra part is the hard part. And we need to simplify this thing. Are all the cosines in the first power now?
Yes.
Okay, but then you can't leave it like this. You have to simplify it. This is a crappy way to leave your answer. You need to simplify it. So it'd be nice if you could just leave it in this crappy form, but no. Okay, so we'll just be methodical about it. Okay, so I'm going to distribute this 3 in. So this is going to become 3 halves plus 3 halves cosine 4 alpha. Is that okay? Okay, I just distributed that in and then I separated the terms. Okay, plus I'm going to distribute this cosine in. I'm going to get cosine 2 alpha all over 2 plus, what happens when you multiply cosine 2 alpha times cosine 4 alpha? Are you allowed to multiply those angles together? Can you take cosine alpha times cosine beta? Are you allowed to multiply those together? No. If you have different angles, you are not allowed to combine them together, just like with roots. If you have different roots under your radicand, you're not allowed to multiply them. Oh, actually, you can do that with roots. That was a terrible example. Yeah, with exponents, thank you. Different bases. Can you multiply them together? No. Okay, so you can't do this. So this just becomes cosine 2 alpha cosine 4 alpha all over 2. No, you're not simplified all the way. I see some things that can be combined together. No, you're not done. Okay, so let's work inside the bracket for a minute. You've got a 1 and a 3 halves. What is 1 plus 1 1/2? I'm going to write it this way, if you don't mind, 5 halves. Okay, any other terms that can combine together? You can only add them together if they have the same theta value. This one and this one. So 3 cosine 2 alpha plus 1/2 cosine 2 alpha. What's 3 plus a half?
3.5.
Thank you. 7/2. And I cannot combine these together. This is like saying 3/2 x, and this is like saying 1/2 xy. Can't add them together. So this is 3/2 cosine 4 alpha plus 1/2 cosine 2 alpha cosine 4 alpha. You have a couple of options here. You can either distribute the 1/8 in, or you could factor out the fraction. I recommend factoring out the fraction. We get 1 over 16 times 5 plus 7 cosine 2 alpha plus 3 cosine 4 alpha plus cosine 2 alpha cosine 4 alpha. You will see this problem again in calc. But you're going to be integrating it.
What about on the test?
Well, you're going to see a problem like this probably on the test. But you don't know about integration yet, so I won't ask you to do integration. But yeah, you have to know how to use the formula for lowering powers. So be meticulous on your homework for tonight. You have a couple problems. We're not done, by the way, but we just have one more example here. But let's see. Problems 9 through 14 are asking you to use the lowering powers formula. Okay, I would say that this is probably one of the hardest when you have a power of 6. When you've got a high power like that and you have to expand into a cubic, that one's tricky. I don't believe the ones that you see on tonight's homework are as challenging. But again, you just have to be meticulous. Okay, the last kind of stuff we're going to see today are these problems where you have to do the proving. Prove the identities are true. Okay, so we've got sine 4x equals 4 sine x cosine cubed x minus 4 sine cubed x cosine x. So you have to decide which side you want to work on. The right-hand side? Okay. Okay, if we work on the right-hand side,
If you know the left-hand side, can't you use it?
how about we do both? Let's work on the right-hand side first. What do you want to do here? Distribute? It's already distributed. What do you mean distribute? That's called factoring. So I want to undistribute. Reverse distribute means factor. So if we factor this, what's left over? If I factor out a 4 sine x cosine x out of all terms. Oh, look at how nice that is. Is that equal to 1? No. Okay. So, go ahead. Yeah, so you've got a cosine 2x. It's cosine squared minus sine squared. Okay, so this thing right here is a double angle formula. This is cosine 2x. What about this? I've got 4 sine x cosine x. I could write this as 2 times 2 sine x cosine x. Yeah, this is the sine double angle. 2 sine 2x cosine 2x. This is sine 4x. It's the double angle formula for sine. So what would it look like if we had done it on the other side? Yes, this is the opposite. Yeah, so if we had done it on the other side, we would have started here and gone 2 sine 2x cosine 2x, and then you would have to break apart the sine 2x into 2 sine x cosine x, and break this apart choosing strategically. Remember that there's 3 different versions of the cosine double angle formula. And then multiply it in.
Could you use the addition formula and get the same answer?
Can you use the addition? Can you say like sine 2x plus 2x?
Yeah.
I don't know. Sine 2x cosine 2x plus sine 2x cosine 2x. So you get 2 sine 2x cosine 2x. Oh, look, it's right there.
Yeah.
So, yeah. Assuming that you would know what to do next, yeah. Uh-huh. Okay, so you've got some homework for tonight on page 548. The stuff we talked about today is not on the quiz. Okay, the quiz is only 7-1 to 7-2.